then the general rule is we can just add the numerators as long as the denominators are the same. So 2 over 7 plus 4 over 7, the result of 6 over 7. And that's the basic principle. Alright? So as long as we can add numerators, as long as we have the same denominators, the numerators can be added. Likewise, subtraction. Let's say we have 6 over 20 minus 2 over 20. Then this result would be 6 minus 2. And again, basic rule, as long as denominators are the same, we can simply add or subtract the numerators. So 6 take away 2, that's 4 over 20. And if you wish, we can always simplify 4 over 20. And again, there's a rule for simplifying fractions. Right? So we want to divide both of these numbers by the same value. And we look and say, okay, 2 can go into both numbers. So we divide the 4 by 2. But remember, a rule, we have to also divide the denominator by the same value, 2. So 4 divided by 2, that's 2. And 20 divided by 2, that's 10. So that's pretty straightforward when adding or subtracting fractions which have the same denominators. Let's now look at the case where the denominators are not the same. Okay, so now we want to look at the case where the denominators are different. Let's say we're asked to calculate seven over 8 plus a half. Now you will recall that the general rule for adding two fractions is that we can only add the numerators when the denominators are the same. Now in this case, denominators are not the same, they are different. So our job is to make them the same. And we do that by finding a common denominator. Usually we use the LCM. And in this case, LCM for 8 and 2, we're talking about the lowest number or the least, we call least common multiple, lowest number that 8 and 2 can divide into. And that such a value would be 8. So we're using 8 as LCM, which means that we want both denominators to be 8. Now this half here is not 8, so we need this 2 to become 8. And how can we do that? We can multiply this 2 by 4. And again, the rule for fractions, whatever is done to the denominator, the same must be done to the numerator in terms of multiplying or dividing by a value. So we multiply the denominator by 4. We need also to multiply the numerator by 4. And therefore now we'll have 7 over 8 plus 4 ones 4 and 4 twos 8. Now please note, it's the same problem. Remember the original problem, 7 over 8 plus half? All we've done so far is rewrite the half as 4 over 8. 4 over 8 is equivalent to a half. So now we have the situation where the denominators are the same, so we can go ahead and add the numerators. 7 plus 4. What's 7 plus 4? 7 plus 4, that's equal to 11 over 8. And if you wish, you can always convert it to a mixed fraction. 8 into 11, that can happen only once. So 8 into 11 one time with a remainder of 3. So 1 and 3, 8. Whichever answer is perfect. Now, interestingly, suppose we're asked to calculate 5 over 6 plus, let me use the same half just to emphasize a point here. 5 over 6 plus half. So again, we cannot add 5 plus the 1, because remember, the denominators are different. And earlier we established that we can only add the numerators if the denominators are the same. So our job is to make both denominators the same. And again, usually we aim for the LCM. And LCM for 6 and 2 is 6. We're talking about the lowest number that 6 and 2 can divide into without leaving a remainder. So we need to get this denominator of 2 to become the same as this 6. And what can we do? We'll always multiply, so we can multiply the 2 by 3. But again, very important, whatever you multiply the denominator, whatever value you multiply the denominator by, you have to multiply the numerator by the same value. Good? So now, let me just separate this problem so to avoid confusion. So now we have 5 over 6 plus 3 times 1 is 3. 3 times 2 is 6. And again, is equivalent to a half. So remember, half can be written many different ways. Half can be written as, well, 1 over 2, 5 over 10, 50 over 100, 500 over 1000, 10 over 20, 15 over 30, 5 over 10, and 3 over 6. But we use 3 over 6. Why do we use 3 over 6? Because the other fraction has a denominator of 6. So we want to ensure that both denominators are the same. And now we can go ahead and add both fractions. So 5 plus 3. So this becomes what now? 8 over 6. And 8 over 6. You can simplify this fraction by dividing both values by 2. Good? So 8 divided by 2, that's 4. 6 divided by 2, that's 3, right? Or if you wish, you can write the answer as a mixed fraction. So 4 divided by 3, that's 1, leaving a remainder of 1, so 1 and 1/3. Any of those 3 forms is totally correct. Now, I'm sure we're having fun so far. Let us look at a few more examples. Let's look at ones where we actually have to do some subtraction. So let's say we're asked to calculate, say, 4 over 5 minus 1/3. Now, when I was in primary school, how I was taught, and I'm sure how many of you are taught, is okay, we put the LCM of 5 and 3, and that's what, 15. And we say 5 into 15, 3, and 3 times 4, 12, minus 3 into 15, 5, and 5 times the numerator, 1, give us 5. And nothing is wrong with that, that's perfect. The only thing I did not know the reason behind this, 12 minus 5, that's what? 7? So our answer would be 7 over 15. Good. I want to look at this in another light, as we did in the previous question when we were doing the addition. Alright, same problem. Look at this. This works perfectly. Nothing is wrong with this method. It's just that I did not know the reason behind this. So we established the LCM is 15. And 15, why? 15 is the lowest number that 5 and 3 can divide into without leaving a remainder. So we want to make both fractions have a denominator of 15. Now to get this 5 to have a denominator of 15, what number can I multiply by? You're correct, 3. But remember, as a general rule, whatever you multiply the numerator, the denominator by, you have to multiply the numerator by the same value. So I also need to multiply the numerator by 3. So 3 times 4, that's 12. And 5 times 3, that's 15. So this is all about rewriting the fraction 4 over 5 as 12 over 15. They're equivalent. Because remember, if you're asked to reduce 12 over 15, you divide both the 12 and the 15 by 3, right? And it will be simplified to 4 over 5. So 4 over 5 is conveniently written as 12 over 15. Likewise, you want to rewrite the 1/3 as a value over 15. So you want to make this, turn this 3 into 15. So what can we do? What number can we multiply the 3 by? Yes, you're correct. 5. But remember again, whatever is done to the denominator, same has to be done to the numerator to make the fraction equivalent. So we have to multiply the numerator by 5. So 5 ones, that's 5. And 5 threes, that's 15. Right? So 12 minus 15, that's same 7. Alright, same 7. So we have a common denominator, 15. And personally, this is my preferred method, because when you're going to do advanced maths, it's very important we understand how to operate fractions in this manner.